So now that we know how to interpret the spectral lines to determine the composition of a star, the last piece of today is to look at using that information to find out if a star is moving towards or away from us and how fast. So we know the spectral patterns, we know how thick the lines are, we know their spacing, and that tells us what element it is. But sometimes we see these shifted one way or another. So the top line of my diagram here, normal spectrum, shows two lines for hydrogen of where around they should be. The blue shift line shows those same two lines, the same spacing, shifted over towards the blue end of the spectrum. And then the bottom line shows them shifted towards the red end of the spectrum. So they're still that same element, they're just slid side to side. So this is a phenomenon known as the Doppler effect. If you haven't heard of that before, go to YouTube and pull up sound clips of the Doppler effect. This is the phenomenon we hear like when an ambulance goes by and we hear its siren change pitch or change notes, if you think in music terms. I actually hear this driving past the TransLink buses when they're beeping to raise the floor of the bus to allow someone with limited mobility to get on. When you're moving past something, that sound wave, or in this case light wave, is either stretched out or compressed, so it sounds like a different note or looks like a different color. So the red shift is for something that's moving away from us. It's the same pattern, but those waves are stretched out over a longer space. If something's moving away, then that wavelength seems longer. You have the same number of waves stretched out into more space between the source and the receiver, which is us. They seem more red. Notice that they're not actually red. They're just slid over towards the red end of the visible light spectrum. And then same thing with blue. They're shifted towards the blue end. Now, granted, this line on the left here is towards the purple end. We don't mean that they are blue, we mean that they're towards blue, because those same wavelengths are squished into less space, which means that wavelength looks smaller, and we see that as a different color of light. So only Andromeda is moving towards us. Most items that we see in the universe are moving away from us, and in a couple of lessons we're going to get into why and what that means. So the amount of shift tells us how quickly something is moving towards or away from us. If it has a lot of shift, it's moving very, very quickly. And if it has only a little bit of shift, it's not moving quite so much. So on this same page of this module, there is a file for you to download called The Signature of the Stars. This comes from the Perimeter Institute, which is a theoretical physics think tank in the, it's not part of the University of Waterloo, but it is located in Waterloo. So the first page of this talks about some of the background information that we've done already. It has the different spectral lines for different elements. It goes through an example of identifying the elements that are present using those reference samples, just like we've just done. And then on the next page, it gives the spectral output of our sun with many, many, many more lines than your book does, which is why we did the book first, start with the easy, and then move into something with more lines. So it asks you to determine what some of these letters represent or what elements they represent. It says lines A and B are due to terrestrial oxygen. When that light reaches our atmosphere, it also interacts with the elements in our atmosphere. So lines A and B are from the Earth and not from the material making up the sun. There's no oxygen making up our sun. The reference lines are on the next page here. This is an activity where if you have access to a printer, it might help you complete it, to print this out and do it on paper. That is up to you. I do think it will be easier that way though. So we use the reference lines to determine what is, what's the significance of lines C through K here. Scroll down. And then it gets into this red shift and blue shift. So what it's done is that it's using two reference lines for calcium because they're quite clear. And they should be right here and right here. And then it's giving data from different stars. NGC is a way of cataloging stars and referring to them in a standard system. It gives the distance to each one of those stars, and then it shows where those lines are shifted to because of that star's motion. So how I do this page is that there's a speed scale at the bottom. So this first calcium line here There's a little bit of a dotted line down to 0 just to mark this is the standard frame. And how I read this page is I take that left-hand line for each of these stars and I extrapolate down to the scale on the bottom and then estimate based on where that vertical line hits what that speed must be. So they've done the first one for you. They've taken a ruler and dropped a vertical straight line down from this line to the scale, and they estimate that it hits at about 2100 kilometers per second, which is a massive, massive speed. So you're going to do this for each one of these stars. And then on the next page, you're going to graph your data. You're going to have the distance on the x-axis times 10 to the 20 kilometers, these numbers here, and your data for the speed on the y-axis to create a graph. There's some questions that follow. If you get stuck on any of them, please reach out by the Google chat and I will be happy to help you. See you next time.